Now we have two new functions. F of x is x over x plus 1 and g of x is 2 over x. You should maybe try to calculate these things before I show them on the video and see how our answers compare. Here, f after g of x is f applied to g of x, so it's f of 2 over x. So when I plug in 2 over x instead of x in the formula for f, I get 2 over x over 2 over x plus 1. Now, the domain of f here is all x values except that unique x value where the denominator equals 0, and that's at minus 1. And the domain of g is all x except 0, because 0 gives you 0 in the denominator. And what's the domain of f after g? Well, that's all x values such that, number 1, x is in the domain of g. We first have to calculate g of x. That is, x is not equal to 0. And secondly, g of x, which is 2 over x, is in the domain of f. And so that's the same as saying that 2 over x is not equal to minus 1, or x is not equal to minus 2. So we have two restrictions: x cannot be 0 and x cannot be minus 2. So that tells us that the domain of f after g equals all x except x equals 0 and minus 2. Well, let's calculate g after f of x, and of course there's a typo there. We should have the domain underneath, and that typo seems to have propagated there. So there are two questions here. G after f of x equals what? Well, this is g applied to f of x, and now our f of x is x over x plus 1. So this is equal to 2 over x plus 1. Remember, I can invert that fraction, and that's equal to 2 times x plus 1 over x. Now, which x values are allowed in this function? Well, for g after f to calculate, I must first of all be able to calculate f of x. So it's all x, such that, number 1, x is in the domain of f, which means that x is not equal to minus 1, and number 2, f of x, which is x over x plus 1, is in the domain of g. That means that x over x plus 1 is not equal to 0. I'll have to figure out which x's over x plus 1 are equal to 0 in order to figure out what I must exclude using that second condition. Well, the only way a fraction can be equal to 0 is if its numerator is equal to 0. So x over x plus 1 can only be equal to 0 if x is 0. So that is, x is not equal to 0. So now we have all x, so that number 1, x is not minus 1, and number 2, x is not equal to 0. So the domain of g after f is all x except minus 1 and 0. What is f after f of x? It's f applied to f of x, which is f applied to x over x plus 1. So I replace every x in the formula for f by x over x plus 1. Okay, now I can certainly tidy that up with my algebraic abilities. So that's just x over 2x plus 1. Now what about the domain? The domain of f after f is all x such that, number 1, I can calculate f of x. Remember, the domain of f is all x so that x is not equal to minus 1. And secondly, x over x plus 1 has to be in the domain of f, so that can't be equal to minus 1. So I must exclude minus 1, but I must also figure out where x over x plus 1 might give me minus 1. I need to solve x over x plus 1 equals minus 1 in order to figure out what I must exclude. I can multiply across by that x plus 1, and I get x is equal to minus 1 times x plus 1, which is minus x minus 1. And then if I bring the minus x over to the left, I get 2x equals minus 1, and that gives me x equals minus 1 over 2. So when x equals minus 1 over 2, that gives me x over x plus 1 is minus 1. And I must exclude that from my domain here. So the domain of f after f is the set of all x except x equals minus 1 and x equals minus 1/2. I have to exclude those from the domain. Now lastly, I have g after g here. Remember, g of x is 2 over x here, and g after g of x is g applied to g of x, which is g applied to 2 over x. So I replace every x in the formula for g by 2 over x. That gives me 2 over 2 over x, which is equal to 2 over 1 over 2 over x, which is 2 over 1 times x over 2, which is just x. Now the formula is simple, but the domain might have some restrictions, so we have to go through the hoops to find the domain. G after g of x has a domain of all x, so that first of all, x is in the domain of g. That means that x is not equal to 0. You can't have a 0 denominator. And second, g of x, which is 2 over x, is in the domain of g. That's the same as saying that 2 over x is not equal to 0. Well, that second restriction doesn't really put any restriction on the x's, because if x is not equal to 0, then 2 over x can't be equal to 0. So the domain of g after g here is all x except x equals 0. Now notice how in this last example the formula for the function was very, very simple. It was just x itself, but the domain was not the domain of the function f of x equals x. It was all x except x equals 0. This is something you have to watch out for, that implicit in the definition of g after g is that you have to be able to first calculate g of x and then apply g of x to the answer. So even though you end up with a nice simple expression for the composition, the domain can be a little more complicated. Suppose I want to express the square root of x minus 1 as the composition of two functions and find its domain. I could write f of x as the square root of x and g of x as x minus 1, and then h of x is f applied to g of x. It's the square root of x minus 1, so this is f after g of x. Now remember, I must be very careful about the order in which I write f and g here, because f after g is not the same as g after f. And what's the domain of this function? It's all x such that, number 1, x is in the domain of g, but the domain of g is all real numbers, so there's no restriction there. But secondly, g of x has to be in the domain of f. I have to be able to plug x minus 1 into the square root of x. And that is x minus 1 must be greater than or equal to 0, and that translates to x greater than or equal to 1. So that's my only restriction there. So the domain of f after g, which is the domain of this function, equals the set of all x greater than or equal to 1.